Welcome to homework.
So for problem 15.195, we have this disk of radius of 3 inches, which rotates with a constant rate of omega 1 full radians per second about an axis held by a housing attached to a rod that rotates with an angular velocity omega 2 of 5 radians per second. This is counterclockwise from the positive z direction. And we need to find the angular acceleration of the disk and the linear acceleration of point P of the rim of the disk for the position shown for the angle theta equal equal to 0. And again, the linear acceleration of point P with theta equals 90 degrees. Okay. First of all, since we need to calculate the angular acceleration, we will do this using the usual formula for expressing the angular acceleration in terms of quantities. From a rotating frame, we need to choose a rotating frame. I hope it is clear that the most convenient choice for a rotating frame would be a frame that rotates with the rod attached to the housing. Therefore, the angular velocity of the rotating frame will be the same. With the rod, this is just a vector omega 2. And our observer now on this rotating frame will only see the disk rotating. So the observer will only see angular velocity omega 1, vector omega 1, but the observer won't see any rate of change of this angular velocity because it is constant. Now, for the specific instance that we see on the drawing, omega 2 is just 5 radians per second I hat. And now omega 1 is 4 radians per second k hat. I'm not using prime indices now, just because we are working under the assumption that momentarily the two frames coincide, the fixed and the rotating frames coincide. And this will give us an angular acceleration of minus 20 j hat radians per second per second. And this is the answer for the first task. This relation will be very useful for the next two tasks. We need now the linear acceleration of point P of the rim of the disk. For this one, we will use this formula. Vector RP is the position of point B. Omega is the vector omega is the angular velocity of the disk. This can be simplified as well, vector Vp is the velocity of point P, the linear velocity of point P. Now, from the drawing, someone can see that position of point P from the fixed frame can be expressed in terms of the angle theta as following. This is in inches. And now for the angular velocity of the disk, we need the angular velocity of the rod plus the angular velocity, of the disk with relative to the rod. So this is just vector omega 1 plus vector omega 2 as we used them before. So immediately this gives us 5 I hat plus 4 k hat. This is radians per second. Okay. Let's begin with the case of theta equals 0 degrees. This gives us position just 3 I hat inches. Therefore, velocity, which equals the cross product of the angular velocity to the position, is just 5 I hat plus 4k hat cross product 3 I hat, which is immediately 12 j hat. This is inches per second. And now we need to do the following calculation. Again. It seems that this is not so complicated. Minus 20 j hat. We just have to be careful. Cross product 12 j hat. And if someone does the calculations carefully, this will give minus 48 I hat plus 120 k hat. This is in inches per second. And maybe it will be better if we write it in feet per second. In order to do this, we just have to divide by 12. So it's quite straightforward. Minus 4 I hat plus 10 k hat feet per second. And this is the answer for task B. Let's do really quickly the case for theta equals 90 degrees. For this case, the position of point P is 3 inches j hat. Velocity as we did before is as this result. I hope it is clear how can we derive it. This is inches per second, as always. And so now, for the linear acceleration, let's rewrite the formula. Minus 20 j hat cross product 3 j hat. So immediately it's just 0 plus 5 I hat for k hat minus 12 I hat plus 15 k hat. If someone does calculations carefully, this gives us minus 75 j hat minus 48 j hat, which is just minus 123 j hat. This is inches per second per second. And again, let's convert to feet per second. Just divide by 12. And this gives us minus 10.25 j hat feet per second per second. And this is the result for task B. Excuse me, task C.